Session 8. Transverse and longitudinal waves. Waves transfer energy and information without transferring matter. Describe what oscillates, which means vibrates, in a tidal wave. Water molecules. What vibrates, what oscillates in a sound wave? Air molecules. Describe evidence that with water and sound waves, it is the wave and not the water or air itself that travels. If you had a little bob, I don't mean little man, that bob would just move up and down like that as the wave travelled. The bob would not travel towards the seashore if the seashore was over here. And that would be the same as the air particles. What does frequency mean? It's how many vibrations there are per second. Give an example. When I ping my ruler on the edge of a bench, it might go up and down 10 times a second. So that's a frequency of 10 Hertz. What does wavelength mean? Draw it on a diagram. Wavelength, length of a wave. Haha! Simple as that. So here is a wave. So it is from one position on the wave to the same position on the next wave. And we put a symbol lambda. It's like an upside down letter Y. What does amplitude mean? It's the maximum displacement. Draw it on a diagram. So just say you're holding a rope, and that's where the rope is when you're not wiggling it. As soon as you start wiggling it up and down, the wave starts going up and down. The amplitude is from the zero displacement position, where it was at the start, up to the top of where the wave gets to. Or it could be from the middle, the zero displacement, down to the bottom. Be careful. Some people think it's right from the top of the wave to the bottom of the wave. That is not right. Define period. Well, the time period is 1 over the frequency. So the period is the amount of time that it takes for one complete oscillation or one complete wave to be produced. Define wave speed or wave velocity. Well, that's just how fast the wave's travelling, isn't it? Same as any speed, really. It's the distance that a wave will travel per unit time. So that's the distance that a wave will travel per second. So it could be 4 meters per second. Just like if you were walking or running. What is a transverse wave? Sketch a diagram. Transverse wave goes up and down. The vibrations are at 90 degrees. 90 degrees to the direction of travel. Give 2 examples. You can have any electromagnetic waves such as light or radio. What is a longitudinal wave? Sketch a diagram. Right, a little bit trickier. The way I like to draw it, just draw some lines, spread them out like that, and then pick one of the lines and do a lot of lines next to that. Miss a one out, and then draw a lot of lines next to that. Miss a one out, draw a lot of lines next to that. Your wavelength could be from the middle of those, what we call compressions, to another compression. These bits in the middle, where it's spread out, called rarefactions. Give 2 examples of longitudinal, sound, and ultrasound. Or you'd say a P wave which is a seismic wave. In other words, an earthquake wave. So for this one, I could have said earthquake wave. I could have said S wave for the transverse. S wave. Now, some people can't remember the difference between a P wave and an S wave. Which one is longitudinal? Which one's transverse? It's easy. Look at this S. If I turn it on its side, it goes up and down, doesn't it? So that helps you to remember the S wave is a transverse wave. Boom! 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 Right, I've got to label these things, have I? Right, so from that position, it's at the bottom, and that position's at the bottom. They're identical positions, so that's the wavelength. And there's from the middle up to the top. That's the amplitude then. Q is a particle in the wave. Which of these shows the way in which particle Q moves? Put a cross in the box next to your answer. Well, Q is just going to go up and down, isn't it? So it's going to be A. Water waves are transverse waves. Give one other example of a transverse wave. Well, I could say gamma, light, X-rays, you know, any of the electromagnetic waves. Give one example of a longitudinal wave. That's the same as before. It's sound, or P waves, or ultrasound. Here's a water wave going up and down, shows you the height of the wave and the distance from the source. What is the amplitude of the wave? Easy peasy. What's its maximum displacement? Come across here. It's about 2.8. Bang, 2.8. What is the wavelength of this wave? Okay. So starting from 0, do a complete wave, back to exact same position. That's 15. And that's how to take care of business with that. Thank you very much, and bye for now. Boom! Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now. Work hard and be nice.